In this tutorial, what we're going to do is take a look at designing the PCB for the Draw a Lump project. What I've got here is the circuit diagram for the project. Hopefully you've put together one of these by now. And what I've also done is I've added a little bit more just over here, which shows how the download socket is wired up. And you finish the PCB, you'll know there's a little headphone jack on the top. That's this thing just here. And it's actually got 3 different connections on the bottom of it. One of them is a connection to the negative end of the battery. The symbol represents the negative end of the battery. One of them, the middle pin, goes to pin 7 on the Genie chip. So this chip and this chip are the same thing. It goes to pin 7, and then one of them, one that actually sends the program in, is connected through 2 resistors. There's one resistor that goes from the leg of the socket through a 22k resistor and into pin 2. There's a second resistor which goes from the pin on the socket through a 100k resistor and off to the negative end of the battery. And I've drawn that just on the side here. So all of that's connected so we can put a program on. I'm actually going to delete that before we get into this process. So hopefully this is what yours looks like as we're going in. To start the process of designing a PCB, we click on this little icon up here at the top of the screen that says Convert to PCB Layout. This window comes up, we'll click on Next. We'll choose the bottom option, it says Rat's Nest. At the bottom, we'll click on Next. Just click on Next again, click on Convert, and we are ready to create our PCB. Here's all the components that are going to get soldered in. So we've got here, that's where the battery's going to go. There's the Genie chip, a couple of LEDs, there's your LDR there, that's a buzzer. Our download socket we just talked about, look, and all the different resistors that we need. And we can hover the mouse over the resistors and see the value of them. So that one's the 100k, so that's going to go with that download socket. A bit later, I think that one there's 22k, that's going to be to do with the download socket, and we'll start popping the other bits in. The process to build a PCB is to flick backwards and forwards between the circuit diagram and the PCB screen. You can do that down here at the bottom. Look, there's my circuit diagram, PCB layout, and we'll flip between the two quite a lot. My strategy for designing the PCB is going to be to start with the power, I think. I'm going to start by adding in the positive end of the battery, this voltage regulator, probably this capacitor actually, and then after that I'm going to add the Genie chip and the download socket. So I think that's going to be my first components, and then I can add the other things in really in any order after that. So battery first, voltage regulator and capacitor. So as I look at the circuit diagram, I can see that the positive leg of the battery goes to the input pin on the voltage regulator, goes on the input pin on the voltage regulator, and you can see that the negative end of the battery goes to this ref, this ground pin just here. So let's start by adding just those 2 things, battery and regulator. Right, so this here is the battery. I'm going to pop that up in the top left corner. Stick that up there. Here's the voltage regulator. Yep, voltage regulator, so you're coming along as well. I'm going to stand that up next to it. Just to save me some time later, I'm going to get the capacitor as well actually and pop it up here, and then we can start to think about wiring it in. Okay, zooming in a bit more. This view that we're seeing here at the moment isn't very helpful. It does give you an idea of what your PCB would look like if you looked at it from the top, looking straight down. But really I'm interested in where all the little legs are, where the holes are, that all the components are going to be put in. So I'm going to change the view to this one here that says unpopulated. So I get this nice X-ray view. You'll notice you've got these very faint green lines as well. It's showing you how everything should be connected up. It's up to you how you feel about these. I find them a little bit confusing actually from time to time, so I tend to go through and delete all the extra bits of label that you get. You can see some bits in there. I tend to delete some of those. I tend also to delete quite a lot of the green lines actually by right-clicking on them and choosing delete as I go along. I just find them a bit of a distraction. You can leave them in if you wish, it doesn't really matter too much. So let's have a look. So this is the positive leg, that's the negative leg of the battery. This is my voltage regulator, and as I hover the mouse over the different legs of the regulator, I can actually see what they do. Okay, you'll see that one's output voltage, reference, input voltage, and I said that according to my circuit diagram that the positive leg of the battery wants to connect to here, so I need to draw some track between those 2 components, a PCB track. And there's definitely a bit of thought needs to go into it. I could, using this track tool up here, I could run a track coming out, going down, going in, and I could connect that up just like that. The middle pin, that's got to go to the negative end of the battery, because in my circuit diagram, the middle pin goes to the negative end of the battery. But I start to bump into problems already if I do this, because I can't cross over the tracks. That's one of the rules of designing PCBs. They can't touch, and so I'd have to start going, okay, come out, go along, go up, go in. It's starting to look a little bit scruffy. Or I suppose I could come out the back, go around, go up, go in, go down, and then tuck in there till it touches. I could do that as well. But what seems the most elegant way for me to solve the problem would be to take this one and to actually rotate it around. There's a rotation tool up here, look. And so I'm going to rotate that 180 degrees, and I can actually sit them quite close together now, and I get a much more natural fit. So there's that input voltage, there's the input voltage there. So that now when I draw my first two tracks on, that goes onto there, that one can come out a little bit, can go onto there, and those two components are placed. They're nice and close together, the route is nice and direct. And as far as possible, all the way through designing the PCB, you want to try and do that. Let's add another component, so let's get this capacitor, remind ourselves what we need. So here's the capacitor. The positive leg of the capacitor is going to be connected to the output pin of the voltage regulator. The negative leg of the capacitor is going to go to the negative end of the battery. Let's try and do that. So you can see that's the positive leg, that's the negative leg, that's the output pin of the regulator. That's going to go there to there. So I'm going to do a bit more rotation, putting that positive leg down at the bottom. I'm going to drag that so it sits there nicely in line. That's that one connected up. Now this one needs to get to the negative leg of the battery. And something you realise once you've done a few of these is that you can make it quite easy for yourself. I mean, let's just pause and think about a couple of options. You might look at this and say, right, so there's the negative leg, so I've got to come across a bit, up a bit, round a bit, down a bit, and in. You might look at it and say that, and that is valid, that would work. But it's worth remembering that this piece of copper here that solders this on, there's a continuous unbroken connection all the way to here, look. So in actual fact, anything on there that's touching is also the negative leg of the battery. So I can actually draw a track from here to here, and that is the same as what I had a moment ago. And again, still nice, compact, easy layout. Right, let's keep going. Let's look at a bit more. We'll do the Genie chip next. Whenever I'm building any PCB, I always do it the same way. I generally tend to start with the power, like I've got here, these three things. Then I add the Genie chip, and then after that I add all my inputs and all my outputs. The reason's quite practical, and it's because the Genie chip's got lots and lots and lots of legs on it, so it's kind of a central point for our circuit. I'm also going to do the download socket, because that's got a few complicated wires in it, so I need to handle that as well. And you remember I had that at the start of the tutorial. Here we go. Right, so zoom back out. You can roll the mouse wheel forwards and back to zoom in and out. You'll notice, since I went to the unpopulated view, it's very hard to tell what component's what. So what I tend to do is to grab this piece of PCB and enlarge it to cover everything, so I can see the outlines again. It just makes it more comfortable to read. Right, Genie chip, we'll pull you up and pop you up over here somewhere. About there. Download socket. I remember from seeing the PCB, I know the download socket sits above the chip, so I'm going to place that up here. I'm going to have it kind of hanging over the edge of the PCB, and then there's the two download resistors, which are the 22k and the 100k. I'm going to stick those up out of the way and then zoom back in on the area of the PCB I'm interested in by rolling that mouse wheel away from me once again. Now here's the download socket. Let's just have a look at what we've got. Move that down a little bit, I think. So I've got a couple of resistors I'm going to put in here in just a moment. As I hover my mouse over the legs of the Genie chip, I can see pin 1 there, that's power, and actually that little faint green line is telling me that that needs access to power, so there's going to be a track there when I'm done. I've got another one here which is for ground, or the negative end of the battery, so that's got to get here somewhere, and I've got this download socket as well. What am I going to do next? I suppose I'll probably do these resistors actually. Just something from experience that I've picked up. The rest of the circuit's a bit easier to do than this. Delete these labels actually. What you want first is this 100k resistor, and you want to rotate this and stand it in this gap just here. And I'm just going to put the label inside there. I'm going to take the 22k resistor and rotate it and stand that just underneath like that. Move that down a little bit more. And I'm now going to do some wiring up for these parts. This is the only part of this that really is a memory test. The rest of the whole process is really nice and straightforward, but all the chips I ever download all look like this, and then they get changed later. So here we go. With this one, we said that the programming pin, so over here you've got a ground pin, over here there's the programming pin. We said there's a 100k resistor between the programming pin and ground, so I can actually draw that piece of track there to there. Once you've finished drawing track, you notice I'm drawing track. Once you've finished, if you right click once, okay, then it basically ends that particular piece of track. Okay, I don't need that one. Anyway, the other half of this goes onto here. The other thing that we said that we have is a 22k resistor, which goes through this into the programming pin, which is this one down here. So it goes through this, connect that up. And then what I'm going to do is quite a clever little trick. We use this quite a lot in circuit design. I'm going to come in and down. I'm going to connect the programming chip, the programming leg that way. So that way I'm still not crossing any tracks. I'm using that gap, that space inside the chip to get the sort of result that I want. The other one that needs to be connected up is the status input pin, status output just here, and that's a straight connection to this this pin just here. So this is easy, no resistors this time. So I'm going to come down, I'll just try and just duck out of the way of that other track, and I'm going to come in there, and that's now connected up. One thing I haven't done yet is take the ground leg, this leg here, and connect it to the negative end of the battery. But just like I did with the capacitor, the negative end of the battery is anything on this big run. And so the easiest way to deal with it is to run a track from there straight into there, look. And now that's connected to ground as well. While I'm here, I might as well do the next logical part with this this chip, which is to make sure that the Genie chip's got power and ground, power and negative end of the battery. So a source of power for this is just here. And so to be nice and neat, I'm going to run, again just following it reasonably close but not touching, nice and neat into there. So that's got power now, so that's that part done. The other thing I need is a connection to ground, which is here. And so for ground, I've got a big load of ground all around here. A couple of ways I could do it. It's always good to explore your choices, and the more you do this, the more you get used to doing it. I could go from here and out and down and round and up and then I suppose trace along here a little bit. I could do that, that would be okay, but that wouldn't be ideal because I know I've got lots of other components, switches, LEDs, all those things to put on here. And if I box myself in like this, it's going to be difficult to find room for all my switches, my LDR and all those things later. So I don't really want to do that. There's actually a clever little route you can take, and you get used to spotting these as you go along. The route I'm actually going to take, depending on what I want to get to here, okay, is I'm actually going to try and go this way around instead. So this is good, check this out, here we go. So I'm going to come from here, I'm going to come out, up, along, and I can just connect it onto there. So I know that there's a continuous, unbroken run back to the negative end of the battery. And that's a really nice way of doing it. So I quite commonly do that. We do it like GCSE projects as well. It's a really good little shortcut. Okay, so that's the first part of the board done, and anyone designing this would probably come up with the same type of solution. The part now, where if you start to feel confident, and you don't have to come through this whole video with me, okay, you can have a go at doing this for yourself. I'll do a couple of parts, and as soon as you feel confident, have a go. If you get stuck, it's not the end of the world. Here's what we're going to do next. Let's get back to the circuit. I think what I'm going to add on next is probably my, let's have a look, 6, P4. Yeah, I think I'll probably have a go at doing the, just having a quick look at this. I think I'll probably have a go at doing this LED next, this one just here, output G4. And the reason I'm going to do it is because it uses pin 3 on the Genie chip. And let me show you which one pin 3 is. Pin 3, and let's just see what we've got here. So it's going to go from pin 3 through a resistor, through an LED, to the negative end of the battery. So pin 3, resistor, LED, negative end of the battery. Got it. Right, so when you look at Genie chips, and or chips in general across the world, they're all numbered exactly the same way. They start in the top left-hand corner. That's called pin 1. You can see that here. The one below it's pin 2, below it's 3, below it's 4, and it's like drawing a horseshoe. So it then jumps over here. So that one's 5, 6, 7, and then 8 over here. The reason I chose pin 3 is because everything that's going to go on pin 1 is connected. everything that's going to go on pin 2 is connected. And so anything that I need to place on here, I can put in this space, and I know it won't get in the way of anything else. And after that, I'd probably do whatever's going to go on pin 4. After that, I'd probably use this pin because it's up here already, and then I'd probably do that one last. So that's part of why I want it. So I need a resistor and an LED. Let's go on to grab one of those from down at the bottom. These are LEDs. Look, it doesn't matter which one you pick really. There's an LED. There's a 330 resistor. And let's stick in one of those on here. So I'm putting that in, and I'm just going to rotate that 90 degrees. And I think just for somewhere neat, you can put it wherever you like, but I'm just going to tuck that in up here roughly, I think, so it's just out of the way. And I've also got an LED to place. I know I've got to get to the negative end of the battery, so I might pop this over here. You'll notice with the LED, it's got that flat edge just there. That indicates which leg's negative. And so we know with LEDs that it's going to come out through the power out there. So I want this to be the other way around. So the LED is going to light up because an LED only works one way around. So I'm going to pop that around about there, and then let's add some track. So it comes out of pin 3, tucking in nicely, following it around nicely, goes to there. It then goes through the resistor, comes out there, into that LED, and out the LED, off to the negative end of the battery. So that's that one all finished. That's lovely. What's next? G4, and again, as soon as you feel confident with this, just have a go, okay? Nothing's going to catch fire if you get it wrong. Pin 4, G3. Let's have a look on that one. G3. Okay, so G3 is a switch and a 10K resistor. The switch is connected to that output pin on there. The other side of the switch goes into the input. The input also goes through a 10K resistor, and that goes to the negative end of the battery. And you can keep checking this as you go along. So switch, 10K, here we go. So zooming back out, a bit of switch down here somewhere, swap, that's good. A bit of 10K resistor down here somewhere as well, I need one of those. And let's zoom back in. Okay, so let's have a look. I need access to power. That's power. I'm going to need some of that. And one end of this is going to be connected on here. So I think what I'll do, I'll probably leave it that way up. You can always change it. There's no harm in doing that. I'm going to leave it that way up, I think. I'll deal with that resistor separately in a moment. So with the switch, one end of the switch we said goes into here. So that was nice and easy. The other end of the switch connects onto power. So power is anywhere along here. And one of the ways I'm going to do that is nice and easy. You know that we can't cross over any tracks, but this resistor, that's soldered on top of the PCB, so I can cut through here, look, to get a real nice convenient connection to that. So that's that part of the switch done. We also know with this, going back to the circuit, looking at the 10K resistor, that from the pin, it goes through one end of the 10K resistor, the other end goes to negative. So it's got to be the 10K, one end of it's got to come on here somewhere, the other end to the negative end of the battery. I wonder if we can do that neatly. This looks pretty good. Always trying to make it compact as far as we can. Here we go, it comes down there. And then that one, I might duck it out of the way a little bit, just making sure I don't touch those legs there. There we go, and that takes me off to the negative end of the battery. That's resolved. I'm feeling quite good about this. Right, what's next? What's next? What's next? I might just keep the labels tidy as well. It's nice if you can do the labels tidily as you go along. Right, next thing after that then, let's have a look at G1. Okay, G1. Again, as soon as you get confident, have a go at doing this for yourself. G1. Okay, so with G1, that's the LDR. So it goes from power through the LDR, other end of the LDR into there, and then the pin through a 10K resistor down to the negative end of the battery. Here we go. Right, LDR. That's this thing just here. And I need a 10K resistor. Let's see what we can do. Right, it's that one there. So the tricky thing, and towards the end of the design process, this does start to become a little bit difficult, is getting hold of things like power. So power is here, 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 here. I'm working over on this side of the chip. There is also power down here. I can envisage I'm going to end up having to do something like coming out of here and going around in order to get power. That's not ideal. What I might do is just pause with that for a moment and have a look at the buzzer instead and try and solve that first. Let's just take a look at that. So with the buzzer, what's the buzzer doing? So the buzzer comes out of its pin, goes through a 1K resistor and then into a transistor. Let's give that a go. Okay, so it's still working on it. There it is. There's the resistor. There's my transistor. The nice thing about this is there's no right or wrong way to do it. I could stop and start this video tutorial again and come up with a completely different solution. And really that's one of the things I rather like about doing these. Okay, let's see if we can do something with this transistor for a moment. I am inclined to have it scoop around this way and see how that shakes out. Let's see what happens. I'm going to take this 1K resistor. I'm going to stick it up here. Again, I'm just trying to keep the PCB nice and small, really. So I'm going to pop that, pop that just there. That's got to go to there, according to my circuit diagram. I'm then going to go into my transistor. Let's see which leg's which. It's the base of the transistor that I need. The middle one. Middle one's the base. Let's just see what the others are called. Emitters down there. Yeah, okay, let's rotate this. Okay. So that goes to the base. That was easy. Let's look again at that transistor a bit more. So the base we've done. We've then got this thing here, the collector. The collector goes to the negative end of the buzzer, and the positive end of the buzzer goes to power. Let's do that. And there'll be a buzzer around here somewhere. Big old component of the buzzer. Here it is. Hopefully this will be labelled with positive and negative. That's not labelled. Okay, so we'll just pretend. I'll say that that one is the negative leg. I think I'll probably leave it how it is. I wonder if I can get in this gap. Yeah, that's looking good. So the collector leg, I'm sure that was the collector. Yeah. The collector leg goes to one leg of the buzzer. Again, just trying to be tidy. The other leg of the buzzer goes to power. I've got some power here, 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 here. Oh, that's good. Look, I can cut through there. That's nice. That's nice. Okay, right, that's the buzzer almost done. The last leg of the transistor, this one here, the emitter leg, pretty sure that goes to the negative end of the battery. Yeah, it does. Okay, how are we going to do that? Well, negative end of the battery is over here, so I suppose I could come around the bottom and tuck into there. That looks pretty good, actually. I think I'll probably do that. Yep. Good, happy with that, that's done. And what's left then is this LDR that I was playing with a little bit earlier. Let's see what we can do with that. Still got some problems in here, I think, to resolve, but yeah, I think it'll be alright. Okay, so let's get stuck in. I think what we're looking for then is to get this LDR and to have that connected up over here. I'll solder you in there, I think. After the LDR, it goes through a 10K resistor to the negative end of the battery. I've now got much more convenient access to that than I had before, so let's turn that resistor around and let's plonk you in here somewhere. It's looking good. So the remaining mission is how do we get power to here? Well, that isn't going to be easy, that is for sure, but I can show you a little trick, a little hack that will fix it actually. And it's this. What I'm going to do is I'm actually going to solder a little piece of wire onto the PCB, and I'm going to jump a little piece of wire from somewhere here over to here. And you see this quite a lot in GCSE projects. The way that you can do this is you can click on this little thing called a pad, and that just inserts another drill hole. And I know I've got nice access to power just here. Look, so I'm going to add a pad in there, so it's not touching anything else. And I'm going to add another pad right here. And I'm then going to connect this together. And I know from the circuit diagram that this piece needs to be connected into this pin just here. And what I can actually do, I'm just going to go into real world view just for a second. I need to run a piece of wire from here to here. And you can do that by going project, and then it's PCB components, I think, and then electrical wire. And I'm going to draw a piece of wire from there to there. Not ideal, but sometimes you just got to do these things to make it work. Back to unpopulated view again. It disappears, but you and I both know it's there now. Let's grab our last couple of bits. We've got one more LED, one more resistor. So according to the circuit diagram, output 0, which is pin 7, needs to go through the resistor, through an LED, and down to ground. Let's do it. So through a resistor, I might stick, I've got a nice handy ground connection just here, haven't I? I'm going to put this resistor around here somewhere. I might put this LED up here somewhere, I think, as well, just to keep it tidy, and let's connect up. So I'm coming out, across, up on a diagonal. See, it's not touching, that's good. Through the resistor into the LED, out the LED to the negative, let's just check, yeah, negative end of the battery, looking good. And that actually is a full working PCB. We could manufacture that right now. Just to tidy it up, I'm going to take the remaining bit of circuit board that I've got, shrink it down now to an appropriate size. Like that. Okay. And in real life, what you'd probably do is put a couple of mounting holes on it so that you can bolt it down to a housing when it's all finished. And you can actually test it as well. This is one of the really, really nice things with circuit wizards, is you can test it. If you click on the gallery of bits and you scroll right down to the bottom for power supplies, we'll need to flick back to our real world view to do this. And this is quite impressive. It looks huge when you see it here, but if I get a 9-volt battery, there's one on here somewhere, 9-volt battery, here it is right down at the bottom, PP3 battery with clip. And you grab a PP3 battery with clip and you pop it, this is the actual size as well, okay, and you pop it just off to the side, you'll see just how small it is. Those things, when you hold them in your hand, are tiny, aren't they? When you hover the mouse over this, it'll tell you how big the board is. Now at the moment it's in inches, that's not very helpful. You can convert it into centimetres by clicking down here in the bottom right hand corner once you've finished, and change it to 1 millimetre, and it will then tell you, so this board here, that's still in inches, that's not very helpful. Anyway, you can connect up the battery now. So I'm going to run a black wire into the negative end, run this into the positive end. I can get in here as well. I think there's some switches in here that we can pick up. Momentary switches. Grab a push to make switch. Pop that over here somewhere. And again, from one end, I'll run that into that terminal. One end into this terminal. And then what you can do is, and I usually go into current flow view to do this as well, you can click on play. Computer will complain, always does that. Just click on OK, and what it will do is it will show you the electricity flowing through your circuit. Look, so here's the power coming in, there's the power going out and going down to here, and things like in a moment, if I push this switch, you'll see this bit here go red where the circuit's completed and power flows into that input. Look, and you can see the program starting to run, that LED's come on, it's starting to do all different things. You can click on the LDR, you can change the resistance, and as you do that, look, the amount of voltage coming through all starts to change. And so you can see that your circuit works visually. You can see the negative end of the battery, look, all the electrons returning back to the battery once it's all complete. Anyway, so that is how you design the PCB.